Okay, radon is a natural source of radioactivity. What's the name of radioactivity? That's natural and around us all the time. It's called background radiation. Okay, explain why radon in the air is a greater risk to health than solid americium in a smoke alarm. Okay, first of all, both are sources of alpha radiation, and remember the properties of alpha. Alpha can't travel far in air, just a few centimeters, and it can't penetrate the skin. In fact, it can be stopped by skin or thin sheet of paper. So both produce alpha. So how come alpha in one is more dangerous than the other? Well, look at the information given. Radon gas is a gas in the air, so you can breathe in radon gas, okay, which then gives out alpha particles, which can then damage your lungs, because the lining of the lungs is very thin, so the alpha particles can damage living cells. Alternatively, the solid americium is solid, so it stays where it is. It stays in the smoke alarm. Okay, radon 222 has 86 protons. Right, the 222 tells you the number of nucleons, that's the neutrons plus protons in the nucleus. The 86 tells you the number of protons, and the number of protons determine what element it is. So radon always has 86 protons. So the answer to the first one is 86. The second one, radon 222 has 136 neutrons. Okay, this number here I said is neutrons plus protons. Okay, and we know that radon is 86 plus 136 neutrons equals 222. Radon 220, it must have 86 protons plus the number of neutrons equals 220. Okay, so you can see that it's going to be two less than the previous one. Okay, so the number equals 134. Answer B. Okay, the activity, the unit is in becquerels, or BQ, and explain what the term half-life means. Alright, you can either describe half-life in terms of the activity, in which case you would say the time taken for the activity to halve, or you can say it in terms of the number of radioactive nuclei, in which case you'd say the time taken for the number of radioactive nuclei to go down by half. Okay, to find the half-life, you choose a point on your graph. So I'm going to choose a nice convenient one at 700. Halve that value, so we're going to go down to 350. Draw a line across. Okay, and then where it hits the line, and draw a line down, and the half-life is this time interval, time taken for it to come down by half. So in this case it is about 55. So 55. Actually, there's a range of answers you can give. 55 plus or minus 4.